but you can see my screen, right?
Very well.
Okay, perfectly. Well, my name on Twitter is Semantic Fire. That's very appropriate. So I do something with semantics and I do something with fire. I thought this presentation, the slides were in English, but unfortunately they're not. So I have to do on-the-fly presentation. I discovered it only 10 minutes ago. I run a company called Netage. We've been around for 25 years and we focus specifically on linked data and graph technology within the emergency response sector. We do that on a global scale. And besides that, I'm also a career firefighter in the Amsterdam Fire Department. So you can see me on the lower right corner just before I entered this burning house with some of my colleagues, where we were actually able to save a father and this 3-year-old daughter from the back. These things, so there's running this Netage and being a firefighter, are brought together by two things, and that's my fear. I'm afraid that something will happen to me, or either my colleagues or the people we serve, and that in the end we figure out that we had the information to prevent that from happening, but we were not able to get to it. So information integration is for the emergency services is our key work field, and we believe that semantic technology is the only way to solve that, knowledge graphs, etc. So let's take this as an example. It's for a couple of years ago. So at 7:09 in the morning, somebody calls the dispatch and says there's a fire in a garage. 24 seconds later, they tell, oh, the wall, the front of the garage come fully outwards. And 2 seconds later, we get multiple calls. Supposed to be a commercial property. The whole thing is on fire. Well, you can see in the background. That's pretty accurate, probably. So the thing is, what do we think of as firefighters if we go on such a call? What would the 4 minutes that we have? And then at some point you realize that we have a lot to think about, and mostly it's unstructured. And that is the puzzle we try to solve, where we hope that semantics and all sorts of algorithms can help to filter out the information which is really relevant. One of the things we're interested in is information about the building, and this is from the Institute of Physical Safety in the Netherlands, who did a research a couple of years ago, and you can see it's from January 2014, where they looked at which are the data sets and the features we are interested in from various buildings, etc. And they figured out that we probably have 25 data sets, both publicly and privately, which say something about buildings, and they all help us to create this picture of where we go to. But as you can imagine, the fire service does not have the time to go over all these 25 data sets. And I always tell people that it's socially not accepted that the fire service pulls up in front of a burning building and spends like another 2 minutes in scrolling on their iPads in the fire truck. So the KRO, that's the abbreviation for it. It combines a set of sources about buildings, about taxes, about Chamber of Commerce, child care, the height of the buildings, and some other information. But the only problem was what they did is they created just another database. I'm going to skip these slides because they're not relevant for this presentation. So here we see on the red dot is the actual location of where the fire was alerted. And what they did is they created this database which contains all the information from all the data sets. As you can see, the whole problem with this is that the semantics of all this data is completely gone. It's just a flat set of properties, and you have no clue what it is. And well, there's some booleans in there as well, where you as a semantic web person were like, why on earth are they even in there if there's no data behind it, etc., etc. And there's multiple versions of the same data. And sometimes you have multiple data sets describing one building. So it's not really logical to do that. And we can see something on the neighboring departments, and that is probably the garage that they talked about, where they said the whole wall came out. We can find something about the surroundings, so you can get quite a bit of information on the businesses around it, But still, as you look at it, all this data is basically everywhere in the in the data set, and there's no semantics behind it, what things mean and what the provenance actually is. Oh. So what we did a couple of years ago, we did an Inspire Arena tender where we thought about, we take this specific problem, we're going to build a knowledge graph out of it, and that's what we did. So an hour and 45 minutes later, there came a recognition as, okay, the fire started at a certain location. There's been an explosion there. The other ones are not affected, but because the chemicals in some of the other buildings, we need to know more about, and we want to see if we can prevent escalation of this incident. And as you can see, it's a pretty decent incident. This is from across the canals in Amsterdam that you could actually see the fire burning. And well, they were not joking when they said the whole facade came out, because as you can see, that clearly did. So one of the things we tried to do in this part was to see if we could take the idea of, I think I'm going to stop this one, stop sharing the screen. So one of the things we wanted to do is, instead of sort of the traditional way of taking all these various data sets with spatial features and try to map them on one feature and have all the information everywhere, could we create a knowledge graph where we would be able to say, from a spatial extent, get all the information in the back end of all these data sets, and see what is actually available. Because the traditional way within the emergency services was, well, you simply enable all the various map layers, so the geospatial way, all the various map layers on screen. And that had a couple of issues. The first issue was that you needed to know which of the map layers were actually interesting. Second, you needed to understand how these things actually relate. One of the problems is that even if you draw a pin through a map and various map layer sticks, the relationships between the various map layers is semantically not defined in a geospatial system. So, and that is where semantic systems actually can play a role. So we've built this this demonstrator, and we actually have this in production at the Amsterdam Fire Department. The only thing is I have to make sure that I can share that part in a different screen. Let me try that one. So can you see my screen now?
Yes.
Perfect. I probably need to log in again. Yeah, I was afraid of that. So this is our fire graph product, a knowledge graph for the fire service, which runs within the Amsterdam Fire Department. And here we have the map of Amsterdam. And if I would basically zoom in, you can see all the buildings. And the traditional way of getting most of the information about these objects would to have like a ton of map layers here and select the map layers and show the information. We decided, can we take a completely different approach and say, oh, maybe I just want to click on a specific building and then see what kind of properties there are. And these are official codes for the data sets for the Dutch government. And now if I click on it, what happens is that it will actually go through the knowledge graph on the fly. So this is a real-time querying and show all the properties on the various data sets for this specific property. So instead of me needing to figure out which are the data sets which are relevant, it just shows everything it actually knows about this specific location. And we simply use a graph query in the back end. Let me see if I can try to find something else. This is a bit smaller one. And actually there's, because we're talking about incident response, there is a historic incident part here as well. And you notice that there is only the information which is actually relevant is in there. So if I take this one, for example, you see some other things popping up. And one of the things that is now available in here is there is a kindergarten in there, and suddenly it shows from that map layer, which is from a geospatial perspective is still a map layer. It now shows that here within the knowledge graph. So there's 74 git places. And it's also interesting, we had a couple of fire incidents there. Probably nothing serious, but at least we can show that. So to show you that this is still a knowledge graph, I can actually go and explore this specific incident and say, okay, find me the object, and you see this object number here again. And here we can see, oh, we have a child daycare facility. And here you see the 74 kit places, and we have a we don't have, well, that's interesting, there's no business attached to it. Well, we have a building part here as well, and we're browsing through the geospatial data as if it was a knowledge graph. So one of the things we did in this part is looking at how can we build this bridge between the geospatial infrastructure and the knowledge graph. How can you go from geospatial representation of features on the map and actually quickly link into your knowledge graph? And that is something, like I mentioned earlier, that I was on spatial data on the web working group. If we go to the map, we go back to the map and zoom in again. There it is. And now I need to quickly see. Can you actually see my developer tools from the browser or not?
Developer tools on the left-hand side, OEG viewer?
No, the basically the debugger for Firefox.
No.
You don't see that, right?
No, it's not shared. I think you only share one window.
And now?
Yes.
Yeah, okay. So what happens if I click on the location? You see that it basically does a geospatial request to the National Geo Register of the Netherlands, and this is so we're only showing the official data set provided by the Dutch government, and they have done something based on the recommendations we've written in the spatial data on the web working group. They've done something pretty interesting. We have a RDFC also reference in here, which basically means if you want to see the geospatial or the linked data representation of this feature on this specific map, this is where you can get it. And for the fire graph, we basically say, oh, we get this data and we now pick up this URI and send this URI to our knowledge graph and basically ask the knowledge graph, what can you tell us about what's going on at this URI? And then it will answer that it knows two specific objects. So it says, oh, I have these two specific objects, or just one specific object there. And if I copy that link and would go to the Explorer again, let me close that one. Nope, it's not capable of parsing. That's a demo effect here for you. Oh. There you go. So there you have the object again. So that is how we bridge this gap between sort of the spatial and the commercial and the semantic world. So one of the things we're literally currently working on is that for a fire service and to make the most interesting bits and pieces out of these this whole how do you say that knowledge graph, is if you would go to a certain street and have a fire there. Let me quickly, where is our demo street? And you go to a specific apartment in any of these buildings, you'll notice that all these buildings have certain characteristics. So one of the things we're currently doing is ask the knowledge graph with the geospatial query, give me, and we're using Stardock in the back end, give me a machine learning model with a set of specific features to this building and find me the similarities to the other objects within within this space. And the reason that we are interested in that is that if you look at where firefighters get into trouble is where they run into the unexpected, the unknowns. So we are now doing experiments where can we pick any apartment in Amsterdam and see how much this is different from all the apartments surrounding it. Because if you have a street with 70 square meter apartments, and then the fire department goes there, they're probably thinking that they will have a fire in just another 70 square meter apartments. But we have places where they have like 200 or 300 square meter apartments because they did all sorts of loft conversions. And those are the ones that are potentially get us in trouble. So we're using the geospatial mapping of find me all the relevant objects nearby, build a machine learning model, and then tell me how much of a difference there is from the current apartment where I go to the apartment that I'm actually having the incident in. So that is where we now do the combination between the geospatial part and the semantic part. And we can use the knowledge graph because we can now say, I want to have multiple features from multiple data sets, which are to be taken into account to build this, this model. I think that's it. And I'm talking too long already, I guess. So yeah.
Oh, very good.